Hey YouTube, Booth Dog back. Let's go ahead and jump right into today's lessons. Your participation seems to be pretty consistent, but that doesn't mean it's as high as I would like. So please, it doesn't really do much good for me to say this here. But if you're not watching the videos, please watch them. I realize that means you probably aren't watching this now. But really, if your friends aren't doing their work, especially you seniors, some of you need this class to graduate, you need some of your other classes to graduate, it still matters, okay? Push yourself, keep going, okay? So let's bring Mr. Boothman on, and let's get started. Good morning, happy Wednesday. So we're off to a start on our second to last unit, Unit 8. Your exit ticket for today will be very similar to yesterday's exit ticket, where I will ask you some basic questions about today's lesson, and you'll just have to type in an answer, okay? These are not for a grade, it does count for attendance, lets me know how we're doing, and this is due by midnight tonight. All right, so yesterday we talked about sequences. So we talked about what a sequence is and how we define a sequence. There's two main ways we define a sequence. Either it's a straight function, so like a function, we have an explicit formula that will give us any term in the sequence. Our input is the term number, our output is the term value. Alternatively, sometimes we define certain sequences as recursive sequences, so each term depends on the term before it, or perhaps several terms right before it. So those are ways of describing a sequence. Today and tomorrow, we're going to look at the two main types of sequences. So how do we get from one term to the next? What rule are we following? The first type that we're going to focus on today is called an arithmetic sequence. Arithmetic sequence. Now, when used as a noun, we pronounce this word arithmetic, of course, like adding, subtracting, very basic. As an adjective, like it's used here, it is pronounced arithmetic. So this is an arithmetic sequence. And an arithmetic sequence is a sequence of the form A1, and then A1 plus D, and A1 plus 2D, and A1 plus 3D, and so on. So the difference between one term and the next is this value of D. And notice it's staying constant as we continue to more terms. So A1 is the first term of the sequence. Okay, should make some sense. This D constant, well, it's the difference between one term and the next. So we call this the common difference. Very creative, I know. Then the nth term of an arithmetic sequence is given by a certain formula. So we want A sub n. Notice that no matter which term we have, it's always based on whatever the value of the first term is. So we know where we're starting, this first term, A1, and then we're adding some multiple of this common difference. That should make sense, right? If we're adding that to get to our next term, we should just keep adding multiples of it to get to any term in the sequence that we want. Well, if we're looking at the nth term, how many multiples of this difference should we add? Well, for the second term, we added 1 multiple. For the third term, we added 2 multiples. For the fourth term, we added 3 multiples. So to get the nth term, we need to add 1 multiple less than n. In other words, we need to add whatever n is, n minus 1 multiples of d. So go back through that, think through that. It's a little weird to start, but hopefully that where we just got that should make some sense to you. And this formula right here is going to be incredibly useful to us as we look at our examples for the day. So, looking at example 5. If a1 equals 2 and d equals 3, find the nth term of the arithmetic sequence. All right, well, we know that this formula gives us the nth term, so we should just plug in these values that we know. So an equals 2 plus n minus 1 times 3. You can leave it like this. I would be perfectly fine with that. Sometimes this form is a little more useful. We can also simplify this. Now, I know it's weird because we're writing this single number after our binomial, but we still need to distribute this in. It's still multiplying. So we could also write this as an equals 2 plus 3n minus 3. And we could simplify that even a little further. 3n, 2 minus 3 is negative 1. So whether you write it like this, or you go ahead and simplify it completely, totally up to you. But both are perfectly acceptable, and both give us the nth term. So this is an explicit formula. All we have to do is plug in the term number that we want, and this formula, either in this form or this form, will give us the term value. Part B. Given this sequence, all right, so now we have a different sequence. They want us to find the nth term of this arithmetic sequence. So what two values do we need? We need a1, and we need our common difference. So a1 is 9. And we need our common difference. So how are we going from one term to the next? This is an arithmetic sequence, so we are adding some number to get to the next. Notice adding a negative is also allowed. Okay, so in some sense, adding or subtracting a number to get to the next. And that number that we're adding, we can see, is negative 5. So our common difference is negative 5. Again, you can leave it like this, or you can simplify it and write this as 14 minus 5. Okay. Let's look at part C. All right, they want us to graph this equation. Okay. Now, this is just a function. An explicit nth term formula is just a function. A sequence is a function. It's just written in a slightly different way. So I know when we're graphing, we're a little more used to seeing a y and an x, an input and an output. In this case, we can rewrite this so we see those familiar variables. Our nth term is our output. So let's call that y. And what is our input? What are we plugging into this function? That's n, so we'll call that x. Okay. And now I'll simplify this a little, distribute the two, and combine our like terms. So we have a more familiar function. What kind of function is this? Well, hopefully you guessed correctly. It is a linear function. And negative 1 is our y-intercept, 2 is our slope, so up 2 over 1. So what do you notice about this graph? It's linear, first of all, pretty important. And what does our d value represent? So looking at our original formula, d equals, it's this 2 right here, d equals 2. And what is 2 in this function on this graph? It's our slope. And this would work no matter what arithmetic sequence we have. That common difference is our slope value. That's pretty important. And in fact, this is where you have seen, in theory, sequences most extensively. This was back in Algebra 1, where you learned that linear functions are the same thing as arithmetic sequences. Pretty powerful stuff. Let's look at example 6. Find the first 5 terms and the 300th term of the following sequence. Now, generally, you should have at least 1 or 2 more terms of the sequence to be absolutely sure you know the rules for it. Here, I mean, we know we're talking about arithmetic sequences, so we know there will be a common difference. To find the first 5 terms and the 300th term, we need the nth term formula. We need A1, which is 13, and we need our common difference. So how do we go from 13 to 7? We subtract 6 or add -6, so D equals -6. So our nth term formula is 13 plus n minus 1 times -6. If you choose to simplify this, you get 19 minus 6n. Knowing this formula allows us to pretty easily answer this question. We want the first 5 terms and the 300th term. Well, we already know the first 2 terms, 13 and 7, though if we plugged 1 and then 2 into this formula, it should give us the correct answer, and we see that it does. It would give us 13 and 7. Okay, we plug in 3, we get 1. We plug in 4, we get -5. We plug in 5, we get -11. And we plug in 300, and we get -1,781. All right. One last example for today, and this last example is the most difficult kind of problem you will see for arithmetic sequences, and you'll see why I'm calling it difficult in a second. It's not actually that hard, it's just a little tricky. Might not know how to set it up, so we'll go through it here. Find the nth term of the arithmetic sequence and the 1000th term. Given the 11th term is 52 and the 19th term is 92. Let's start with what we know. We want the nth term. And then this would give us the 1000th term as well. In order to find the nth term, we need the first term and we need the common difference. They didn't give us either of those pieces of information here. What they did give us was that the 11th term, so A11, is 52, and the 19th term, A19, is 92. Here's a little, I hate calling it a trick. In math, I don't like saying there's really tricks, but here's how we would approach this problem. Okay, here's what you should remember to do this process here. We know A11 equals 52, and if we were using this nth term formula to find this value, this would equal A1 plus, well, we're looking for the 11th term, so this n would be 11. 11 minus 1 times our common difference. And A19 is 92. If we were to use this formula, we'd have whatever the first term is plus, in this case, n is 19 minus 1 times d. And let me pull these two out. Let me simplify this a little. We have 52 equals A1 plus 10d, and we have 92 equals A1 plus 18d. We have two equations with two variables, A1 and d. I'm going to use a little process you've learned in the past called elimination. You can also use substitution if you wish, but the way I've written it, it's kind of all nicely set up for elimination. I want to eliminate this A1 variable, so I'm going to subtract our second equation. 52 minus 92 is -40. A1 minus A1 is 0. 10d minus 18d is -8d. And now I can solve for d. So d equals +5. Now that I know d, I can plug this into one of these two equations. I'm going to plug it into the first. 52 equals A1 plus 10 times 5. So 52 equals A1 plus 50. A1 equals 2. Now that we have A1 and D, we can solve for the nth term. Okay? In this case, the nth term equals 2 plus n minus 1 times 5. And of course, you can simplify that as always. And the 1000th term then equals 2 plus 1000 minus 1 times 5, or 4,997. Again, this is the most difficult type of arithmetic sequence problem you will come across. The only difficulty here is realizing that we can set this up as a system of two equations. Having those two equations, we solve it like any other system of equations, solving for our two variables. That lets us find an, and then any other term in the sequence that we want. We'll look at the other main type of sequence tomorrow. So today, again, was arithmetic sequences. Tomorrow we'll look at the other type. You do have that exit ticket due by midnight tonight. And then I encourage you to continue working on the 8.1 independent practice that I posted yesterday. Please join our Google Meet with any questions. Reach out to me if you're having any issues. Otherwise, have a good day. That's it for today. Thanks, Mr. Boothman. Thanks, all of you. Let's keep going. Let me know if you have any questions. Come to our Google Meet. See you tomorrow.